I'm in a spring mood. We're going to write in yellow tonight. I'm hopeful for warmth. Okay, so let's finish up the ratio test. I wanted to hit the last example in more detail from Wednesday. And I think it was number 17 in your textbook. Yeah. I want to make sure it's the right one. Yep, it's 17. Okay. So the series was k equals 1 to infinity of k factorial squared over 2k factorial. And with the ratio test, you're comparing the a to the n plus 1 term. You're creating a ratio of these two sequences, these two successive sequences in the series, and you're looking at the limit. Okay, you're looking at the limit of these two, right, as n approaches infinity, and if that limit is less than 1, you know, if the limit is less than 1 or greater than or equal to 0, then the series converges. Okay, so recall that the series is going to converge. Okay, so the setup of the problem, I tried to go around the classroom on Wednesday to see if you guys were setting them up okay, and I think everybody was able to do that. So the limit is k goes to infinity. The numerator is k plus 1, so wherever there's a k, you're going to replace a k plus 1. So k plus 1 factorial squared over 2 times k plus 1 factorial over k factorial squared. This is just your a to the nth term in the series. 2k factorial. So here we have to play a little bit of an algebra game. And obviously that's going to be the hardest part, I think, for most of you with these series, is working on that ratio algebraically and try and get it into a simplified form that you can actually take the limit of it. So let me scroll down a little bit. Oh, I want to keep that up there. All right. So this becomes the limit as k goes to infinity. Right, you're just going to take this term, flip it, and multiply it. So it's k plus 1 factorial squared over 2k plus 1 factorial times 2k. That denominator on the at the bottom here is going to flip up, so it's 2k factorial over k factorial squared. Okay, I'm gonna pull a couple things aside and point out some things to you and some tricks. So I think I'll write in red. And aside. All right, I want to look at this ratio to this ratio. Okay, I want to try and match things up. And then I'm going to look at this to this. Okay? They have like terms, so I want to just kind of make a ratio of those individual pieces and work on them. So the first one I want to look at is k plus 1 factorial squared. And I'm going to divide it by k factorial squared. And it looks like we can do something here, and sure enough, you can. So the numerator is nothing other than a factorial that goes 2k plus 1. All right? And that's squared. The denominator is k factorial squared, so that's 1 times 2 times 3 times k squared. Okay? Now, algebraically, you could pool, right? Remember, those exponents go to each term, okay? Goes to each term. So this is the equivalent of 1 times 2 times 3 times k squared times k plus 1 squared over 1 times 2 times 3 times k squared. So these two things can cancel out, and what you're left with up top is k plus 1 squared. Let's look at the other two pieces, the factorials of 2k and 2k plus 2. So I'm going to pull this out next and look at 2k factorial over 2k plus 2 factorial. So if I work on this, the numerator, remember the factorial is taking whatever is inside. So this is 2 times 1 times 2 times 2, right, times 2 times k. That's what that numerator says, 2k factorial, divided by 2k plus 2 factorial. So that's 2 times 1 times 2 times 2. Okay, what I did here was just, by the way, I just distributed in the 2. Okay, so continuing out like that probably was easier for you not to see it in that form. Let me think about that for a minute. So this is 2k, and this is 2k plus 1, the next term, and the final term is 2k plus 2. Okay, we went 2 more. We went 2 more beyond 2k. Okay, so that cancels out, and what you're left with is this piece. All right, so it equals 2k plus 1, 2k plus 2. All right, so there are your two pieces. Let's put it all together back in the limit form. So scroll back up. This limit is actually equal to, probably not going to have enough room here. You know what, let me take it downstairs, down a little bit further. Okay. All right, I'm going to have to scroll over, guys. Oh, no, I have some. Okay, so what this boils down to, putting it all back together. Let me grab green. Putting it all back together, this becomes a limit as k goes to infinity. The numerator was k plus 1 squared. The denominator was 2k plus 1 times 2k plus 2. Okay, so what I have to do here is FOIL this out. So this becomes the limit as k goes to infinity of the numerator is k squared plus 2k plus 1 over, FOIL this out on the bottom, 4k squared plus 6k plus 2. And you know that these are this is the highest power in the denominator, so this thing is going to equal 1/4. Hopefully you can see that without me going through. What you would do is divide each term. Maybe I better do that. Right, you're going to divide each term by k over, or by k squared. Oops. In both the numerator and the denominator. Right, so this is 4k squared over k squared plus 6k. There's a lot of algebra with this, and a lot of algebraic tricks. So I really want you to look at this carefully. So this is going to go to 0, this is going to go to 0, this goes to 1, this goes to 4, this goes to 0, and this goes to 0. So you're left with 1/4. Okay, which is less than 1? Therefore, this thing converges. By the ratio test. That's a long video. My longer ones. Okay. Yeah, watch this a couple times if you need to.